All right, so let's take a look here at problem number 4. They want us to solve this equation. These trig equations will often have infinitely many solutions. We want to find the general solution and then restrict our answers to be just those that are between 0 and 2 pi. So let's get this secant by itself. Let's add 1 to each side. So we have the secant of this angle, x over 2, is equal to 2. I know that secant and cosine are reciprocals of each other. So if I change the secant to a cosine, then I need to take the reciprocal of the right-hand side, and the reciprocal of 2 is 1/2. So now I look to my unit circle in quadrants 1 and 4 for an x-coordinate that's 1/2. And in the first quadrant, we find that at pi over 3. And any angle that's coterminal to pi over 3 will also have an x-coordinate of 1/2. We also have in quadrant 4 at 5 pi over 3, that x-coordinate is also 1/2. Let's multiply everything by 2 to solve for x. And you can see it has a bizarre effect that dividing the angle by 2 here is actually a horizontal stretch, and we're going to lose solutions on 0 to 2 pi. If you stretch it out, then some of those solutions are going to be stretched out beyond 2 pi. Let's multiply everything here by 2. Let's write this second term with a denominator of 3. It'll make it easy for us to add. So we rewrite 4 pi as 12 pi over 3 in both of these equations. I'm going to shrink this up a little bit to give myself some room. Because these equations describe infinitely many solutions, but they don't want infinitely many. They only want the ones that are between 0 and 2 pi. So let's call these solutions 1 and these solutions 2, and let's construct a table. If we allow n to be -1, then these angles, the -12 and +2, that's going to be a negative angle measure. We only want positive angle measures, ones that are greater than 0 and smaller than 2 pi. So we're going to start out by letting n be 0. And our first equation gives us a solution of 2 pi over 3. And our second equation, if we let n be 0, gives us 10 pi over 3. Now, let's rewrite 2 pi as 6 pi over 3. Well, you can see already that this 10 pi over 3 is too big. That for this horizontal stretch, that point, that 5 pi over 3 got stretched out beyond 2 pi. So we're not going to include it in our answers. And you can see, I believe that you can easily see, if we let n be 1, then in this first equation, the 2 plus 12, that's 14, and that's definitely bigger than 6 as well. So we're not going to include these two angles. They do satisfy the equation, but they're not between 0 and 2 pi. That was a horizontal stretch, and the only solution that we have on 0 to 2 pi is this 2 pi over 3. It's the only value between 0 and 2 pi that satisfies this equation. If I go to plug it in the calculator, however, I don't have a secant button on that calculator, so I'm kind of have to jump down here and use this equation that I've rewritten that in terms of cosine. So let's use that and see if the calculator agrees. I'm still in radian measure from my previous problems. If I have the cosine, and I'm going to put my numerator, my x, in parentheses, this 2 pi over 3. And then divide it by 2, close that parentheses, and this should give us a value of 1/2 or 0.5 as a decimal, and it does. All right, so that's in our solution set. All right, well, I hope that helps, and I'll talk to you later. Bye.